So let us start with a classical definition or mathematical definition. The definition says, if a random experiment has n possible outcomes, and if these possible outcomes are mutually exclusive, exhaustive, and equally likely, and if m of these outcomes, that means what is said, the random experiment has how many possible outcomes? N possible outcomes. And if out of these n possible outcomes, m outcomes are favorable to an event A, then the probability of occurrence of the event A is defined as the ratio m upon m. Symbolically we write PA. PA means probability of occurrence of an event A equals to m upon n. So what is this n? This n is the total number of possible outcomes of a random experiment, and m is the number of favorable outcomes. M is the number of favorable outcomes. That means probability of an event is defined as number of favorable outcomes upon total number of possible outcomes. And of course one condition is imposed here. These total possible outcomes, this should be mutually exclusive, exhaustive, and equally likely. Now one thing should I say, what is the maximum value of this m? And what is the minimum value of this m? I give you an example. Suppose I throw a dice and the possible outcomes are 1, 2, 3, 4, 5, 6. And these 6 outcomes are mutually exclusive, exhaustive, and equally likely. So in this type of example, n equals to 6. Now suppose I define an event A of getting an even number. That means out of these 6 possibilities, 3 even numbers are there. That means number of outcomes favorable to an even number is 3, namely 2, 4, and 6. So see here the value of m is 3. So probability will be 3 upon 6. Now if I declare another event B, an event can be declared with any block letter A, B, C, D, F to X, Y, Z. You can use any block letter. Now suppose I declare an event B of getting a number less than 1 when a dice is thrown. That means experiment is throwing of a dice, total number of possible outcomes n equals to 6, and here how many outcomes will be favorable to B? What is B? B is an event of getting a number less than 1. Now when a dice is thrown, no number is there less than 1. So in that case, what will be the value of m? 0. So in that time the required probability will be 0 by 6. That means 0. So that means the minimum value of m is 0. Suppose I declare another event C as an event of getting a number greater than 0 when a dice is thrown. So when a dice is thrown, the total number of possible outcomes n equals to 6, and how many outcomes are favorable to C? That means how many outcomes are greater than 0. So all these possible outcomes 1, 2, 3, 4, 5, 6, these are greater than 0. So in that time, what happens? M equals to 6. That means required probability will be 6 upon 6. That means 1. So we see that the minimum value of M is 0 and the maximum value of M is N. When M will be 0? If none of the possible outcomes are favorable to the concerned event, and when M will be equals to N, if all the possibilities are favorable to the concerned event. So that means when M equals to 0, the probability becomes 0. When M equals to N, the probability becomes 1. So you see, the probability always lies between 0 and 1. We can express these probabilities in percentage form also. If probability is 0, it means that 0% chance is there for occurrence of that event. That means that event will never occur. If probability is half or 0.5, so we express in percentage as 0.5 into 100%. That means 50%. That means 50% chance is there for the occurrence of the event. And if probability is 1, that means 1 into 100%. That means 100%. That means 100% chance is there for the occurrence of event. That means that event will always occur. Now, if A denotes the occurrence of an event, then symbolically A bar denotes the non-occurrence of the event A. That means if PA denotes the occurrence of the event A, denotes the probability of occurrence of the event A, then PA bar denotes the probability of non-occurrence of the event A. And how can I evaluate the probability of non-occurrence of the event A? Now see, in the definition it is said that out of n possible outcomes, m outcomes are favorable to an event A. It means that if m outcomes are favorable to the event A, how many outcomes are not favorable to the event A? N minus m. N minus m outcomes are not favorable to the event A. So that means PA bar, that means probability of non-occurrence of the event A, is given by n minus m upon n, because n minus m outcomes are favorable to the event A bar, or we can say that n minus m outcomes are not favorable to the event A. So PA bar equals to n minus m upon n, or I can say just 1 minus m upon n, or 1 minus p, or 1 minus PA. So PA bar means 1 minus PA, or we can write this way, PA plus PA bar equals to 1. So what can be concluded? Probability of occurrence of an event plus probability of its non-occurrence equals to 1. Some limitations are there, and the definition fails if the outcomes, I mean the possible outcomes, are not equally likely. And another limitation is there, if the exhaustive number of outcomes is infinite. So under these two conditions, that is, if the possible outcomes are not equally likely, or if the total number of possible outcomes is infinitely large, in these two conditions we cannot apply the mathematical definition. You see, if the total number of possible outcomes is infinity, that means something divided by infinity. So ultimately the probability will be undefined. So under these two conditions we cannot apply mathematical definition. And this drawback is overcome by the relative frequency approach, or that is also termed as the empirical definition of probability. So let's have a look on a simple example. What is the chance of getting an even number when a dice is thrown? So when a dice is thrown, the total possible outcomes are 1, 2, 3, 4, 5, 6, and these are mutually exclusive, equally likely, and exhaustive. That means simply we say that n equals to 6. N means total number of possible outcomes. Now I declare an event A. Let A be the event of getting an even number. Now, how many outcomes are favorable to A? Out of these 6 possibilities, only 3 possibilities are favorable to A, namely 2, 4, and 6. So the number of favorable outcomes, M equals to 3. Now, can we apply the mathematical definition? Mathematical definition can only be applied if the total possible outcomes, are mutually exclusive, exhaustive, and equally likely. And when a dice is thrown, these 6 possibilities are mutually exclusive, they are exhaustive, and they are equally likely. So we can apply the mathematical definition, and as per the definition, number of favorable cases divided by total number of possible cases. That means 3 upon 6 or half, or 0.5. You can express in percentage also 50%.